Good morning everyone. We will be starting with new topic, that is precast reinforced cement concrete. As the name suggests, these are precast or prefabricated construction techniques which includes those buildings where the majority of structural components are standardized and produced in plants in a location away from the building and then transported to the site for assembly. These components are manufactured by industrial methods based on mass production in order to build a large number of buildings in shorter time at comparatively lower cost. Now, precast construction is efficient and fast. Precast concrete is produced by casting concrete in reusable molds or by using highly advanced machinery, then cured in controlled environment and then transported to the construction site and lifted into place. Generally, there are various stages that are majorly divided into on-site, that is off-site, that is factory environment, and on-site, that is cast in place. So the off-site stages include design of the prefabricated members, then production, then curing, and finally the storage. And on-site stages include storage, the transportation, installation, and finishing. Now, there are some main features of this type of construction process. They are like the division and specialization of human workforce. So, you require some specialized human workforce for this particular type of construction. Then, the use of tools, machinery, and other equipment. They are generally automated in the production of standard interchangeable parts and products. So, compared to site cast concrete, precast concrete erection is faster and less affected by adverse weather conditions since the curing is already done in the plant itself. Then, plant casting allows increased efficiency, high quality control, and greater control on finishes. So, this type of construction requires a restructuring of entire conventional construction process to enable interaction between design phase and production planning in order to improve and speed up construction. So the concrete elements cast and cured in manufacturing plant and then transported to the site, as I have already explained earlier. Plant casting allows increased efficiency and higher quality control. At the bottom you can see a typical photograph of prefabricated structure plant. They are durable. Permanent steel forms are reused many times and reducing formwork cost compared to site cast concrete. If you compare a scenario on the site, the number of reuses are comparatively very less. So in that words, this process turns out to be economical. Use of type 3 high early strength cement and steam curing allows concrete members to be cast and cured in as little as 24 hours. Controlled casting conditions and high quality forms allow for greater control of surface and finishes. So you are aware about the curing situation in the site cast concrete. So in the absence of automated curing conditions, curing takes time. Curing of reinforced cement concrete takes a lot of time as compared to the precast structures, since it depends upon the type of RCC element you are casting. If it's a structural member, then it will take comparatively higher time, and also you will be requiring water at site. So this is already taken care in the plant itself, so you don't have to care about curing in this case. Hence the precast RCC advantages include very rapid speed of erection, good quality control, entire building can be precast wall, floors, beams, etc. Rapid construction on site, high quality because of controlled conditions in the factory. Pre-stressing is easily done, which can reduce the size and number of structural elements. Aesthetic versatility depends upon what type of variety of members you are using. Then durability, security, low on maintenance, and economical. Then there are some disadvantages also. These are very heavy members. As you can see, these are almost like precast concrete blocks, and concrete is almost comparatively heavy. Camber in beams and slabs. So cambering is required to counter the what you can say lifting ends. Concrete is by its own weight sometimes tend to sag while used in building. So to counter that, cambering is required. So for some short angle or a small dimensions, that part is lifted upwards to counter the alterations, you can say, which can be reduced, which is caused by sagging. Connections may be difficult, so there are some specialized type of connections used in prefabricated structures. Then very small margin of error. So you have very small margin of error. Unless and until you can do it very well, you cannot execute the structures in precast RCC. Somewhat limited building design flexibility. So as you have already designed and standardized building elements, so the design flexibility is somewhat limited, you can say. Because panel size is limited, precast concrete cannot be used for two-way structural systems. Then economics of scale demand regularly shaped buildings. So it is difficult to work in organic shapes and all in this type of structures in particular. Mostly these are geometrical buildings. So that limitations you are going to face in precast RCC structures. Then need for repetition of forms will affect building design, you can say. Sometimes you can say that the building design looks very monotonous because same elements are repeated again and again. Joints between panels are often expensive and complicated. So we will be studying this when we study the joinery in detail. Skilled workmanship is required in application of the panel on site. So you are going to require skilled labor to execute this type of work. And then cranes are required to lift the panels. As we have already said, these are very heavy members, so you will be requiring a setup that is required to lift all these heavy panels and place at the exact places where you have to fit or assemble these panels. Now this precast construction is actually divided into or categorized into two major types: architectural precast and structural precast. So as the images suggest, the top left hand side you can see RCC jalis, you can say. So that's an aesthetic elements. Precast concrete members are classified as architectural precast concrete and structural precast concrete. So architectural precast refers to concrete elements that are used as non-structural cladding elements. So the left side image suggests that. and the most common use in precast concrete curtain walls. Then structural precast concrete includes all elements of building. So structural precast includes structures like frame, floors, roof, slab, columns, walls, etc. Although an entire room or assembly of room can also be precast. So you can construct a complete building in precast also. So most structural precast concrete is used in standard elements that are assembled on site to form various types of spaces. We will be studying precast RCC elements one by one. So the first one is precast RCC slab. So there are various types actually. So as you can see in the images, the first one is solid flat slab, then you have hollow core slab, then you have double T, and then you have single T. So the solid flat slabs are the very basic types. It is just like a cast in situ slab or a cast in concrete with some reinforcement. The widths vary. Hollow core slab, you can see the hollow cores, circular cores which are entirely vacant. So that also helps in reducing weight. So need not necessarily be circular. If you go through various manufacturers booklets, you can see those are constructed in rectangular shapes also, the cavity. Then you have double T and single T. So depending upon the span or the length of that particular slab, this type of T slabs are manufactured. So these are comparatively structurally more stronger than the previous types. So all these slabs comes in various thicknesses and various sizes depending upon various manufacturers. Then you have precast RCC beams. So you have these various types. First one is rectangular beam, then you have L-shaped beam, inverted T-beam and I-section, I-shaped beam or Osto beam. So as the image suggests, these are visually similar what you do in cast in situ beams. So in cast in situ conditions also, you have rectangular beam, you have L-shaped beam, inverted T-beam and I-shaped beam also. So the difference is only the protruding reinforcements or the horizontal bars which you can see in the images. So this part will be explained in joinery. So the role of those exposed steel members are for joining these members with the other RCC elements that we are going to study while we study the joinery. Then precast RCC columns. Precast RCC columns are connected together through bolting actually. So in the images what you are seeing is number of columns joined to each other. That can be a single piece also, but generally you get a small room size of column and then you have to join to increase its vertical length. You can also see a corbelled end on one side of a column or one face of a column. So that is particularly for resting the horizontal component, that is the beam. Precast walls, you can see these are visually very similar to the precast slabs. The only difference is these are to be assembled vertically. These also come in various thicknesses and various sizes. Depends upon if it's an external wall, the thicknesses would be more, and if it's a partition wall or the interior wall, the thickness would be comparatively less. Then there are other precast RCC elements also, like staircases. You get a complete flight of staircase which is already precast. You have to just lift it and assemble it on site at the mid landing, as you can see in the left side image. Then typical joineries of precast RCC elements. So there are some typical joinery which you are going to study. So as we saw earlier, members like columns, beams, walls, slabs. So how this joinery is taking place in this particular precast elements. So the first joinery is column to column joint. Okay, so the precast concrete columns are connected together through bolting. The top of the lower floor column contains threaded bolts projecting out, while the bottom of the upper floor column has embedded base containing holes to engage the bolts. The blockouts in the column above, the holes are filled with concrete after the connection has been made. So as you can see the images, in the first image you can see the lower column and the upper column. So the lower column has protruding ends and the upper columns has cavities to receive those protruding ends, and at the both faces of that column, the upper face of the lower column and the bottom face of the upper column has metal plates. So having secured the connection, you have to nut bolt it, and then finally that cavity is filled with the fresh or grout, cement grout or concrete you can say, and finally that joint is made tighter. So once this is fixed, the joinery is achieved in terms of column to column connection. This is very typical connection followed in column to column joints. The next type of joinery is of column and beam joints. So as we have already learnt in the beams, you can see a rectangular beam and a vertical square shaped column with corbel to receive the beams. You can see the beams are rested on the corbel end which column is housing, and if you have a closer look, you can see some metal blocks already fixed in the column and beam. So while casting of these beams and columns itself in the manufacturing plant, metal plate is casted in the external face of that column. So keeping in mind the joinery of this particular elements. So you already have a metal face on a beam. It is present at the top part also and bottom part also. So while resting on the corbel end also have a metal plate. So those two metal plates, the upper part of corbel and the lower part of that beam, so these are going to overlap on each other at the base, and at the top you have the metal plate at the side of the column and metal plate at the top part of the beam. So having placed beam at its place, you have to use a angle section or a angular cleat, angle shaped cleat, which is welded on that particular part. At this part, the angle shaped cleat is to be welded. So one end of the one leaf of that particular angle is going to be welded on vertical part of that column, and the horizontal part is going to be welded on the top part of the beam. So in this way, this joint is secured, the joint between column and a beam. Yeah, so this thing is clearly visible in this particular image. If you can go through the finished horizontal beam resting on corbel, and the angle section what you are seeing in this particular image is the welded angle section. It is also called as angle connector. So this is secured in this way. And now how to secure this slab on this particular beam? So you can see the slabs are placed on either side, and then there are steel bars through the grout keys, and the slab is resting on the bearing pads which is already there on the beam. So having secured the reinforcement, you have to pour cement grout in the gaps to fill and tighten that particular joint. So in this way you have to place all the members in their place, and then secure them by various techniques. Sometimes welding is also done, sometimes nut bolting is also done. Bolting, actually, the protruding members works as bolts, nuts. So this is how the joinery takes place in these are the typical joinery details. Typical joineries of precast RCC elements. Now the joinery of slab. In this particular picture, you can see there are various slabs arranged side by side, and the gap in between is filled by cement grout, and the top part is first placed reinforced cement jali. The reinforcement is welded in this case with each other. The square shaped jali is the welded steel bars, and then cement grout is poured upon this particular jali. So this way you get a clean finish on the floor. If this slab is going to act as floor, you get a cleaner surface, or this can be a exposed slab also. So these are some of the basic joinery details that takes place in the RCC structure, or RCC prefabricated structures, precast RCC structures. So in next part we are going to study the other details of this particular topic.